Good day to all. In today's video, let's discuss about fructosuria. So fructose is an abundant sugar in the human diet. This dietary monosaccharide is present naturally as free fructose or as a part of the disaccharide sucrose. So sucrose, which is nothing but the table sugar, is a disaccharide which when hydrolyzed it yields fructose and glucose. The metabolism of fructose from diet source is referred to as fructolysis. The metabolism of fructose. Normal dietary intake is the majority of the ingested fructose is metabolized by the enterocytes of the small intestine primarily to glucose, which is then delivered to the systemic circulation. The diet contains large amount of sucrose or fructose alone, overwhelm the ability of the small intestine to metabolize it all, and under these conditions a significant amount of fructose is then metabolized by the liver and to lesser extent by other organs such as skeletal muscle. There are two pathways for the metabolism of fructose. One occurs in the muscle and adipose tissue, the other in the liver. In muscle and adipose tissue, fructose can be phosphorylated by exokinase, which is capable of phosphorylating both glucose and fructose to form fructose 6-phosphate, which is then enters glycolysis. In liver, the cell contains mainly glucokinase instead of exokinase, and this enzyme phosphorylates only glucose. Thus, in liver, fructose is metabolized instead by the fructose 1-phosphate pathway. Fructose is converted to fructose 1-phosphate by fructokinase with the use of ATP, and fructose 1-phosphate is then split into glyceraldehyde and dihydroxyacetone phosphate by aldolase, and the dihydroxyacetone feeds into glycolysis at the triose phosphate isomerase step, and then the glyceraldehyde is phosphorylated by triose kinase to glyceraldehyde 3-phosphate using another ATP, and also it enters the glycolysis. Aldolase family. The aldolase family involved in metabolism and glycolysis are present in 3 isoforms: aldo A, B and C. Aldolase A found in most tissues. It cleaves fructose 1,6-bisphosphate to dihydroxyacetophosphate and glyceraldehyde 3-phosphate. Aldolase B is found in liver. Only aldolase B cleaves fructose 1-phosphate, and aldolase C is found in brain. It cleaves fructose 1,6-bisphosphate to dihydroxyacetone phosphate and glyceraldehyde 3-phosphate. And this aldolase allows fructose to be converted into intermediate molecules in the glycolysis pathway, and fructose is metabolized to pyruvate more rapidly than glucose. Disorders of fructose metabolism. So essential fructosuria. Fructosuria is a benign metabolism disorder caused by the lack of enzymes called fructokinase, which is normally present in the liver, pancreatic islets and kidney cortex. The fructosuria disease depends on the time and amount of fructose and sucrose intake. Hereditary fructose intolerance. Hereditary fructose intolerance is an autosomal recessive disorder resulting from a lack of aldolase B, which is normally expressed in liver, small intestine and kidney cortex. The disorder is characterized by severe hypoglycemia and vomiting followed by fructose intake. So prolonged intake of fructose by infants with this defect leads to vomiting, poor feeding, jaundice, hemorrhage and eventually liver failure and death. Fructose 1,6-bisphosphatase deficiency, and this is a hereditary. Fructose 1,6-bisphosphatase deficiency is a very rare autosomal recessive disease. So loss of fully functional FBP result in severe impaired hepatic gluconeogenesis and leads to hypoglycemia, ketosis and lactic acidosis. So these symptoms can take on a lethal course in neonatal. Thank you.